In this lesson, we are going to discuss about cyanide ion. When consider cyanide ion, only carbon and nitrogen are present. So let us first go to the Lewis structure. Carbon will give 4 electrons, nitrogen will give 5 electrons, and it has one negative charge, altogether 10 electrons. So we can just draw these two atoms. So first we will complete the octet of nitrogen because it is more electronegative than carbon. So we used 8 electrons. So we have another 2. It should go to carbon atom. So now here carbon has not completed the octet. So it requires another 4 electrons. Those 4 electrons we have to take from nitrogen atom. So only one lone pair remains now. Now we have to go to the charges. Carbon valence shell number is 4, nitrogen 5. Now here carbon has 5 electrons belong to its valence shell because always we take half from this electron and this electron. Now here there are 2 electrons. Half of the triple bond means 3 electrons. So altogether 5 electrons. Here also 2 electrons plus 3 means 5. So here minus 1 0. So minus charge should go into carbon. Discuss the hybridization. When we consider carbon atom, it has one lone pair and one sigma bond. That means it requires 2 hybridized orbitals. So we can take that from S and P. But here we should not forget carbon has extra electron, that is why it has negative charge. So first we have to add that negative charge, otherwise we will be wrong. So then I can take one from S and one from P. So you can see the lone pair here, it is present there. And this single electron can be used to make the sigma bond. And another 2 p orbitals remain with 2 electrons. Those will be used to create the 5 bond. Now let us consider the nitrogen atom. Nitrogen has also one lone pair and one sigma bond. So it also going to form sp hybridization because it requires 2 hybridized orbitals. So we can take one from S and one from P. Remaining 2 orbitals will be used to make the 5 bonds. So here we do not need to readjust the number of electrons because nitrogen has not any charges. So we can use the ground electron configuration for nitrogen. Now let us talk the oxidation number. For carbon, most stable oxidation number is plus 4 because nitrogen is more electronegative than carbon. So carbon feels it loses 3 electrons because this electron cloud is attracted by the nitrogen atom. So it gains plus 3 charge. So let us say write carbon. It gains plus 3 charge, but again it has already one negative charge. So minus 1. This is would be equal to plus 2. When go to the nitrogen, it feels it withdraw 3 electrons. So minus 3 is the oxidation number. So for carbon it is plus 2. For nitrogen it is minus 3.